Okay, so welcome to the 6.03 mini lesson. This lesson is on combinations. The problem set is problems 1 through 25 odd on page 471 to 472 on the reference guide, so please make sure to complete the problem set before you try to take the quiz after you watch this recording. Okay, so combinations are similar to permutations in the sense that they ask how many different ways can I do this. But the key difference between combinations and permutations is that in combinations, order does not matter. We're bringing or grabbing a group of things, but we don't care what order they're in, so we're not putting them in order. You'll see that the formulas are here. So n choose R or n combination R is the same thing as the permutation divided by the number of ways to put those things in order. Basically what you're saying is I want to grab this many things, but I don't want to count the order. Another way of writing that formula is that it's n factorial divided by r factorial times n minus r factorial. And oops, I should have put this factorial on the other side. There we go. Okay. So we're going to be using that with an example here. So Joey has 35 classmates, but his mom said that he can only invite 6 to his birthday party. How many different groups of classmates could he invite? So the thing is, order does not matter in this case, right? Because it's not like he's ranking his 6 friends at the birthday party. They're just all coming to the birthday party. So order doesn't matter. But he could have a certain number of different combinations of classmates. Since he has 35 and he's only choosing 6, we want to know how many different groups of 6 he could possibly pick. So that makes this a combination problem. So we can use that formula and say, okay, n factorial, divided by, and we're going to be doing r factorial times n minus r factorial. That's all on the bottom there. So what would n be here? N is 35, so it's 35 factorial divided by the r, so the number of people that we're picking is 6, so it's 6 factorial times n minus r, which will be 35 minus r, which is 6, right? Okay, so now we know from experience, of course, that these factorials can get super big, right? I'm going to go ahead and get my calculator open because I definitely don't want to be doing 35 times 35, or 30 times 5 times 34 times 33 times, all that stuff. So, and I'll bring this in here so you guys can see it. So I'm going to type in 35 factorial. Ooh, it's so huge, so huge. Okay, I'm going to back up. Let's just do 6 factorial because we know that's not too bad, right? 6 factorial is 720. So I'm going to reevaluate what order I do this in. I think I said 720, right? Yeah. Now we're going to do 35 minus 6, which is 29. So 29 factorial is really big, but not as big as 35 factorial was. We still don't want to have to write that whole thing out. So what I'm going to do is I'm going to try to put all this in the calculator at one time. So watch how carefully I'm going to put this in. 35 factorial divided by, now I know I have to divide by the 6 factorial, which was 720, and then divided by again that 29 factorial. And that, now that is manageable. 162316. 162316, and then did I have an extra 0 on there? I did. So I'm going to go ahead and write it like this, because that's essentially what I put into the calculator. Notice I had to divide by 720 and I divided by 29 factorial. So that means that there are, wow, right? 1,623,160 and 160 ways that he could pick 6 out of 35 classmates. Is that crazy? Have you ever had to pick a group of people to come to a party or something and you're trying to decide who to bring and who not to bring, and you've spent like forever, right, trying to figure out who you're going to bring and who not? Well, this might be wise because you actually really do have a lot of different ways that you can choose that group of people. Okay, here's another one. Irma is eating M&Ms, but she only likes blue and red ones, so those are the only ones she wants to eat. There are 5 red, 3 blue, 3 yellow, 4 green, and 8 orange M&Ms in her bag. If she's only going to eat 10, how many different color combinations might she pick? Okay, so the thing is here, sometimes there's more information than you actually need. Since she will only eat blue and red ones, we don't need to worry about how many yellow and green and orange there are. So we're just going to write down first that she has 5 red and 4 green. Not 4 green, but 3 blue. So we only care about those, right? So, how many things is she picking from? Right? She'll eat blue or red. She doesn't care whether it's blue or red. She doesn't care what order she eats them in. Right? But we know she's going to eat 10. Oh dear, I guess that's a problem, isn't it? Because she has to eat all of them, and then she would have to eat some ones that are not blue and red. Oh dear, I wrote a bad question here. Okay, let's change this. Sorry guys, every once in a while I do something dumb. Let's say it's 8 blue, okay? Alright, there we go. So now we have 5 red, 8 blue to pick from. She's going to eat 10. How many different color combinations could she pick? We don't care. Alright? We don't care what order they're in. We just know that she's going to pick 10. So that means we're doing 10. There are 10 total. I'm sorry. No, 5 plus 8 is 13. Oh my goodness, my brain. There's 13 she's choosing from, and out of those 13 she is choosing 10. But remember, we don't care about order. So, we're going to say, okay, so n is 13. So it's going to be 13 factorial divided by r factorial. We're choosing 10 times 13 minus 10 factorial. Okay, so let's go ahead and work that out. 13 factorial probably is not too big, so let's go ahead and see what that is. Oh, actually that's a little bit big, huh? Okay, so we aren't going to do that. We're going to wait. So we're going to just say 13 factorial because that's too big for us to be writing out. Divided by, and again, we know 10 factorial, we'll just leave it that way. But we can do the 13 minus 10, which is 3. Right, and I can even make my life a little bit easier for putting things in the calculator and do 13 factorial divided by 10 factorial times 3 factorial is 6. Okay, so now I'm going to put it all into the calculator and see what I get. Okay, so 13 factorial divided by 10 factorial, which is this, divided by 6. 286. So there are 286 different color combinations she might pick. If she's choosing out of 5 red, 8 blue, it could be like that. So she might like do 5 red and 5 blue. She might do 8 blue and 3 and 2 red, something like that. So 286 combinations. So main thing is to apply the formula. If the numbers are actually not that big, but they're too big for doing in factorial form, just to let you guys know, you can actually expand these. And some of you might actually be able to expand them in your head without actually having to write them all out. So this is another way to do them sometimes. It's not always practical. And I'm not going to write the times 1. Well, I guess I will write the times 1, even though it's not necessary. Okay. And I'm going to say this would be all divided by 10 factorial, right? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Oops. Times 1. And then also times 6, right? So here's just another way to do it if you wanted to do it without the calculator. You'd have to be dividing all of that So let me put a division bar in here. Give me a second to format that nicely for you all. Okay, so if I'm going to divide this, something else I can do is I can actually cancel. So I'm going to show you what I mean by that. I'm going to say, look, I've got a 10 on top, so I'm going to cross it out. And I have a 10 on the bottom, so I'm going to cross that out. See, I'm canceling them. And then I have a 9 on top and a 9 on the bottom. And I have an 8 on top and an 8 on the bottom. I have a 7 on top and a 7 on the bottom. I have a 6 on top and a 6 on the bottom. I have a 5 on top, 5 on the bottom, 4 on top, 4 on the bottom, 3 on top, 3 on the bottom. You bored yet? It gets long, right? But I want you guys to see that you can do some of these without a calculator by crossing out a whole bunch. Now I still have a 13, a 12, an 11 on top, and a 6 on the bottom. But look, I'm going to say, look, I can even cross out this 6 and divide this 12 here by 2, or by 6 rather, right? And if I divide that by 6, it becomes a 2, yeah? So I'm going to take that cross mark away since I just deleted it and turned it into a 2. So I divided the 12 by the 6 to get 2. So now I could use my calculator, and I could use my calculator just to do 13 times 2 times 11. And notice that we should get the same thing. 13 times 2 times 11. Oh, and look at that, we still got 286. Not surprising, right? So just know that when the numbers are smallest, you can actually expand those factorials and then cancel things instead of doing a calculator. Just be very, very careful with those calculators that you do divide by both things on the bottom and do not accidentally multiply by anything that's on the bottom. It's really tempting to do like 13 factorial divided by 10 factorial and then accidentally multiply the whole thing by 3 instead of dividing it by 3. But it is on the bottom, so it needs to be divided by 6. And I said 3, I meant 6. I'm sorry. Apparently I'm tired today. Anyway, so hopefully this was helpful. I'm just going to remind you one more time to do the problem set. It is problems 1 through 25 odd on 471 to 472. So please do make sure to do those and turn those in. And don't forget to ask me questions when you have them.